Hello my dear friends, welcome to the YouTube channel Math Skill. Let's learn mathematics together. The aim of this channel is to help students overcome the fear of math by learning the concepts clearly. In this session, let's discuss about the chapter Quadratic Equations, and the numerical what we are going to solve is a statement problem from third exercise, and the numerical is a train travels 360 kilometers at a uniform speed. If the speed had been 5 kilometers per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. This numerical is a part of CBSE as well as NCERT for 10th standard mathematics. I am your trainer Venkatesh K. Now let us begin the solution. I have noted down the problem wherein the expectation is we will have to find the speed of the train, wherein the train travels a distance of 360 kilometers at a uniform speed. Now condition is if the speed had been 5 kilometers per hour more, then it would have taken 1 hour less. That is, if train is moving at higher speed, it should take lesser amount of time to cover the same distance of 360 kilometers. In this case, if speed is 5 kilometers per hour more, it is taking 1 hour lesser. So, to find the speed of the train, we have to satisfy these conditions, build a quadratic equation, and then solve it to find the speed of the train. In order to do that, let us assume the speed of the train to be x kilometers per hour. Now let's note down the given condition wherein he says train is traveling a distance of 360 kilometers. Now distance traveled by train is equal to 360 kilometers. We know a formula in physics wherein which relates speed, distance and time, which is equal to speed is equal to distance by time. Let's note down that particular formula wherein speed is equal to distance by time. Also, since the condition is given in terms of a time, that is the train will take 1 hour less time to complete the same journey. Now let us swap the terms of time and speed wherein time is equal to distance by speed. Total distance traveled is what is given as 360 kilometers, and speed of the train we have assumed as x kilometers per hour, wherein in order to find time taken for this completing this particular journey, let us take time to be t1, that is time taken by the train in first condition, that is t1 is equal to distance is 360 kilometers by x kilometers per hour, wherein t1 is equal to 360 divided by x so many hours. Also, now let's build one more condition wherein he says if speed had been 5 kilometers per hour more, that is if train is traveling at a speed of 5 kilometers per hour more than what it was earlier traveling, then in that case speed of the train would be x plus 5 kilometers per hour. Now in this condition also train is traveling a distance of 360 kilometers, therefore time taken with higher speed t2 is equal to distance is 360 divided by x plus 5. Now he says time taken in the second condition when the train is traveling at higher speed, he says it is 1 hour less. Now let's build that condition, that is t2 is equal to t1 minus 1 hour. So t2 we have already found out as 360 divided by x plus 5 is equal to t1 is 360 divided by x minus 1. Now to simplify and find the value of x, let us transpose 360 divided by x towards the LHS. Therefore, we will be getting 360 divided by x plus 5 minus 360 divided by x is equal to minus 1. Now we see that in the terms of LHS, 360 in numerator is there for both the terms. Let us take 360 common. That is 360 multiplied by 1 divided by x plus 5 minus 1 divided by x is what is left from the two terms is equal to minus 1. Now let's take LCM for the two terms in LHS. Since the denominator of both the terms contains x, that is the value of this particular first term p by q form and second term in p by q form is not known. So to take LCM of such terms, multiply the denominator terms, that is 360 into, to take LCM here in denominator x plus 5 and x are multiplied with this. Now in numerator we would be getting x minus of x plus 5. That is, how did we get this? This x plus 5 is divided to this particular term in L, that is LCM, wherein x plus 5 and x plus 5 have got cancelled. We are left with x multiplied by 1 is x. Similarly, x and x have got cancelled, wherein x plus 5 is multiplied by 1 minus of x plus 5 is what we are getting. Now to simplify, let's open the brackets for numerator. Also in denominator, multiply x to both the terms. That is 360 would remain as it is. Now what we would get is x upon opening this particular bracket, x minus 5 is what we are getting in numerator. Also x multiplied by x is x square plus 5 multiplied by x is 5x is equal to minus 1. So plus x and minus x have got cancelled, wherein we are left with minus 5 in numerator. That is 360 multiplied by minus 5 divided by x square plus 5x is equal to minus 1. So to simplify further, let us cross multiply the terms of a denominator to RHS. Upon cross multiplication in LHS, we would be having 360 multiplied by minus 5 is equal to minus 1 multiplied by terms of denominator, that is x square plus 5x. Now we see that we have minus here and also minus here, that is both LHS and RHS are having minus. Let's cancel this particular minus sign and simplify. 360 multiplied by 5 would be 1800 is equal to x square plus 5x multiplied by 1 is same x square plus 5x. So this 1800 we have got by multiplying 5 with 360. 5 zeros are 0, 5 6 are 30, 0, 3 carry, 5 3 is 15 plus 3 is 18. That is 1800 we have got by multiplying these two terms. Also x square plus 5x multiplied by 1 is x square plus 5x. Now let us transpose plus 1800 towards RHS. Plus 1800 would become minus 1800. That is 0 is equal to x square plus 5x minus 1800. Upon swapping the terms, so we would be getting x square plus 5x minus 1800 equals 0. That is this particular equation. Now we see that this equation cannot be simplified further, as the first term is an x square term, second term is an x term, and third term is a constant term. So since all three terms are unlike terms, they cannot be added or subtracted. Upon comparing this equation with the standard form, we see that the standard form is ax square plus bx plus c equals 0. Now upon comparison, we see that both the simplified equation and the standard form contains the first term as x square term, second term as x term, and third term is a constant term. That is, both these equations are looking similar. Now because it is looking like a standard form, we can find the value of x by following any method, either factorization, completing the squares, or quadratic formula. So it is easier if we do it by factorization. Let us do it by factorization. In order to do factorization, let us multiply first and last term. That is x square multiplied by minus 1800 is minus 1800 x square. X square multiplied by minus 1800 is minus 1800 x square. Also, the second condition to be satisfied is upon addition or subtraction, we will have to get the middle term, that is plus 5x. Now, since the number 1800 is quite big, so to select the factors, let us do the prime factorization of 1800. Upon doing prime factorization, we see that in prime factorization, we see that 2 is available 3 times, 5 twice 2 times, and 3 2 times. Now we will have to rearrange the terms in order to get two factors. Those two factors upon addition or subtraction should give us plus 5x, and upon multiplication should give us minus 1800 x square. So in order to do that, let us rearrange the terms like this, that is 8 into 5 is 40, that is 2 to the 2 to the 4, 4 to the 8, 8 multiplied by 5 is 40, and 5 multiplied by 9 is 45. That is, the two factors can be selected as 40 and 45 because we want plus 5x. So out of these two numbers, so let us take plus for 45x and minus for 40x. That is, plus 45x minus 40x is plus 5x. Also, upon multiplication, we have to get minus 1800x square, that is 45x multiplied by minus 40x would be plus into minus is minus 45 into 40 is 1800, x into x is x square. So upon multiplication, we are able to get minus 1800 x square, and upon addition or subtraction, we are able to get plus 5x. Now let us substitute in place of the middle term, that is in place of plus 5x, let us substitute the selected factors as plus 45x and minus 40x. That is, other two terms x square and 1800 would remain as it is, whereas in place of 5x, let us substitute by plus 45x and minus 40x. Now we see that instead of 3 terms which were there earlier, the equation is now containing the 4 terms. Now to find the value of x, let us take common between first two terms and last two terms, that is out of x square and 45x, we have to take whatever is common. Also minus 40x and minus 1800, out of these two terms also we have to take common. That is, so we observe that out of x square and 45x, x is common. That is, if you take x common out of x square and 45x, so we are left with x plus 45, minus 40x minus 1800, out of this if you take minus 40 common, we would be left with x plus 45. Now we see that x plus 45 is common between both the terms, that is both terms contain x plus 45. Let us take x plus 45 common, wherein we are left with x and minus 40 from first and the second term equals 0. Now when a multiple is equal to 0, that is a into b is equal to 0, either a is equal to 0 or b is equal to 0. That is, either x plus 45 equals 0 or x minus 40 equals 0. That is, upon opening brackets, x plus 45 equals 0 or x minus 40 equals 0. Upon transpose, to find the value of x, upon transpose, plus 45 would become minus 45 and minus 40 would become plus 40. That is, x is equal to minus 45 or x is equal to plus 40. Since x is the speed of the train, x cannot be negative. That is, x is the speed of the train, x cannot be negative. Therefore, the uniform speed of the train is 40 kilometers per hour. This is the required speed of the train, what we have to find out. Thanks for watching the video. Take care.